Friday, we started adding and subtracting fractions. In order to add and subtract fractions, what has to be true?
The denominators. Oh my goodness.
Yep,
Same
that's the
denominators.
Okay, you understood them. Just admit it. You guys understood them. Common denominator, right? Denominator has to be the same. So we practiced a few at the top of the front page where the denominator was the same. And you're going to have a few like that in homework. And then we practiced a lot more where we had to get that least common denominator, didn't we? Now, that was purely an adding section. Not that it's a whole lot different, but there's just a little tweak we have to watch for. The next section we're going to practice is subtracting. So, go with what we already know. As you look at A, is there a common denominator?
No.
No. So we need to
Make one.
get a common denominator. To get that common denominator, take your current denominators and make sure they are factored, right?
Yes.
Does 3y plus 15 factor?
Yeah.
How does it factor?
Yeah, you can divide this by 3.
Yeah, GCF of 3. So I'm going to factor a GCF of 3 out here. When I divide them both by 3, I'm left with
3, 1.
3 times y plus 5. What about the second denominator? 5y plus 25. Is there a GCF? Or
Yeah.
does it factor is what I really meant to ask.
There's a GCF of 5.
There's a GCF of 5. So factor your 5 out. When you divide by 5, you're left with
5.
5, 1.
okay. So, we don't have a ton of room here, but we're going to work with it. Least common denominator.
Y plus 5. Or sorry, that's the most.
Okay, so what's in common in both denominators? So grab anything in common, which is the y plus 5. And then any leftover pieces. What leftover pieces do we have?
3, 5.
There's a 3 and there's a 5. And you can leave your denominator written like that in pieces right now if you want. But also eventually we'll need to put those pieces together in that. What do we know about 3 times 5?
15.
Is 15. So this could also be written as 15 times y plus 5. Okay. Let's start working on our problem then. My common denominator. And I think for this first step, I'm going to write it as 3 times 5 times y plus 5. 3 times 5 times y plus 5. If you went ahead and wrote it as 15 times y plus 5, that's awesome. That's fine. Now, remember, look at your first fraction. Look at what was in the denominator and what my common denominator is supposed to be. What am I missing?
Divide by 5 on both. Top and bottom.
There's a 3 and a y plus 5. We're missing the 5. So I'm going to have to multiply denominator by 5 and
The numerator.
numerator by 5. So we're going to be doing 5 times y minus 1. Now, if you want to go ahead and multiply that right now, 5 times y minus 1, that's great. Okay? Second fraction. Look at what my original denominator was, what my common denominator is supposed to be. What am I missing? I was missing the 3. So we're going to multiply this second fraction by 3. That means I'm multiplying top and bottom by 3. So that means the top I'm going to be doing 3 times y plus 3. As you get better at this, there's lots of steps that can be combined. I'm not going to argue that at any extent. So I'm going to take this. I'm going to put these fractions together. So my common denominator, I'm going to go ahead and put this together. What is 3 times 5 now?
15.
15 y plus 5. Numerators. 5 times y minus 1, you need to distribute. So 5 times y is 5y minus the 5 times 1, so minus 5. Now, are you with me?
Yes.
Here's where we have to be careful. We need to take this 3, yes, and distribute it. But what's the catch here? What type of problem is this? Subtraction. So my recommendation as you go and distribute that 3 is that you think about it as a negative 3. Because somehow or another, we have to think about this as a negative here. Okay? So if I distribute that as a negative 3, negative 3 times y is going to be minus 3y. And here's the kicker. Minus 3 times 3 is minus 9. That's the place you're likely to make the sign mistake. Okay. You've done the tough stuff. Clean it up. In the numerator, what do we know?
So it's 2y.
Oh, that's the denominator.
Back is
Okay. 5y minus 3y is 2y. Negative 5 minus 9 is negative 14. Over 15 times y plus 5. Before we decide if this is final answer, does anything factor?
Yeah.
Does anything cancel? So, if there's factoring, I always encourage you to do it. Does 2y minus 14 factor?
yes.
It does have a GCF of 2. So if I factor that 2 out, I'm left with y minus 7 over the still 15 times y plus 5. Does anything cancel?
No.
Y minus 7, y plus 5 aren't the same. They don't cancel. 2 and 15, if that was a fraction it could reduce, we'd want to reduce 2 over 15, but 2 and 15 doesn't reduce either, does it? So, here's what I'm going to say. I personally am going to say either or. Okay? I did not think to go into Savas and investigate that answer farther as to if there's a factoring but non-canceling situation, do you have to factor? Okay? If you can recognize nothing's going to cancel and you don't factor, I'm okay with that. I just can't guarantee Savas is going to be okay with that. So, either or for me. Questions there?
No.
Okay. I'm debating how much subtraction do we want to do today?
Just these first 3 and be done.
The bottom part has nothing to do with subtraction. The bottom part we're doing. So, well, if we're just doing B or C, I'm going to be more likely to do C.
I say we do B.
But if we're doing B, we're also doing C because I'm definitely doing C is
Did
what
I
I'm
say we
saying.
did just C? All in favor say aye. All opposed say
I love how you think you just get the vote, but
Motion passes.
okay. Let's try C. We'll see. If I have time at the end, I might come back and do B. But let's work on C. Now, C I want to talk about. There's important stuff happening here. What about those denominators on C?
Take a factor.
They can factor, can't they? And at this stage of the game, folks, we're going to assume stuff in this form factors. X squared minus 6x minus 16.
And we're not doing B. 8 and 9.
No.
I'm going to skip B for right now, Jay. I might come back and do it later, depending on how timing goes. So,
Negative 8, positive 2.
okay. Multiplying to be negative 16, adding to be negative 6 is indeed negative 8 and positive 2. X squared plus 6x plus 8.
4 and 2.
X and X, multiplying to be 8, adding to be 6, is 4 and 2, and those are both
Positive.
positives. I don't know if you can write out your least common denominator anymore, but I'm going to write out up above. Is there anything in common?
X plus 2.
X plus 2, X plus 2. After you get everything that's in common, go for your leftovers. What leftovers do I have?
X plus 4 is minus 8.
Okay. X minus 8. X plus 4. Okay. That means both my common denominators have
Same thing.
all three factors, right? So, denominator of X plus 2, X minus 8, X plus 4, minus denominator of
X plus 4
X
is minus
plus
8.
2, X minus 8, X plus 4. And this is me just writing out, setting up for the next step. All I've done is write them both denominators out with my common denominator. Okay. When you're ready, investigate.
Yes.
First fraction, what are we missing from that common denominator?
X plus 4.
We're missing the X plus 4. So that means in the denominator, I'm going to multiply by X plus 4, and more importantly, in the numerator. So that means I'm going to be multiplying X plus 4 times X plus 1. Okay? I'm in the teaching mode, so I'm not going to multiply this together right now. If you're multiplying it together right now, that's fine. Okay? Second fraction. What are we missing from our common denominator?
X minus 8.
We're missing the X minus 8. So that means we're also going to multiply our numerator by
X minus 8.
X minus 8. So it's going to be X plus 1 times X minus 8. Okay. I'm ready to put this together as one big fraction. Common denominator of X plus 2, X minus 8, X plus 4.
What?
In both cases, what are we doing in the numerators?
What's the word? Foiling.
Okay. We need to FOIL these. Okay. So X times X,
X squared.
X times 1,
X.
1X, 4 times X,
4.
4X, 4 times 1, plus 4. Now, me personally, what kind of problem is this? Subtraction. So what I'm going to do is I'm going to put a subtraction sign, and I'm going to start a set of parentheses. We're going to go ahead and FOIL this, and I'll worry about actually subtracting the pieces in my next step. Okay? So I'm just putting this whole thing in parentheses, because it's going to be subtracted later. So that's that right there. X times X squared, X times minus 8,
Negative 8.
minus 8X, 1 times X, plus X, 1 times minus 8,
Negative 8.
minus 8. So that whole section from the second fraction is going to be subtracted. Okay, let me write up my next line. We know our denominator is going to be X plus 2, X minus 8, X plus 4. Okay, everything from the second fraction is being subtracted. So be careful here. X squared minus X squared cancels. My X squareds are gone. Now, we've got several X's to mess with here, don't we? 1X and 4X is 5X. And I don't know how your brains work. I just know how my brain works. My brain on this one is going to say, okay, I know 1X and 4X is 5X. And then my brain is also going to go down here and say negative 8X plus 1X is negative 7X, yes? So now, if I look at 5X minus negative 7X, I'm going to get
12x.
12x?
Well,
Okay. Now, I don't care how you got your x's, but you should have gotten 12x, right? And then for our constants, 4 minus negative 8 is going to be plus 12. Okay. Anything factor?
they're both good.
Okay. Officially, 12x plus 12 has a GCF of 12. If I factor out that 12, I'm left with x plus 1 over x plus 2, x minus 8, x plus 4. Does anything cancel? No. So, Mrs. Sargent is going to say either or. If Samus gets picky, my guess is they're going to want the factored form if they start getting picky with you. So they may let it be either or as well, but if they don't, that's going to be their picky piece, okay? Okay. B, if I have time at the end of class, I'll come back and do B for those that are interested in seeing it.
I'm just wondering if we're going to do it.
It'll depend on timing. So, okay. I want to spend a little bit of time on the bottom because this subtracting wasn't really a whole lot different than what we did on Friday. Not really. Just matter if you remember what we did on Friday, right? But the bottom section, it's simplifying a complex fraction. Complex fractions are when you have fractions within fractions. And they just look kind of ugly, don't they? There's no nice way to describe them. They don't look pretty. Now, I'm going to, on A, B, and C, we kind of have one method I'm going to talk about. D, I'm going to treat a little differently just because on D, I can clearly see one fraction divided by one fraction. So D, I think, will be a little bit more reminiscent of other things we've done. A, B, and C is not just a fraction divided by a fraction, is it? There's adding and subtracting along with fractions divided by fractions. So, on all of these, we're still going to talk about least common denominators. What I want to know is what is the least common denominator with the current fractions. So in this case, in the numerator, what common denominator do we have? X. What denominator do we have in the denominator? X. What's the common denominator between X and X?
X.
That's X. Okay. What we're going to do with that X is not that, there's a couple different ways I can teach this. It's not that we're going to get that common denominator. We're going to multiply by that common denominator. And what's going to happen is that's going to clear out all the extra fractions. So, we're going to take the numerator and multiply it by X. We're going to take the denominator and multiply by X. Now, in these cases, this means we're going to take this X and it has to multiply by both pieces. So we're essentially going to be distributing it. Now, we're beginners. I'm going to show my steps, okay? So this means I'm going to take 2, multiply it by X. Minus, I'm going to take 1X and multiply it by X. I'll clean this up on my next go round, okay? In the denominator, what are we going to do? We're going to take X and multiply it by X, and plus we're going to take 2 over X and multiply it by X. And again, each do them their own. If that's too much writing out and you don't want that, then don't do it. Now, let's look at cleanup. On top, what is 2 times X?
2x.
Minus 1 over X times X. And here's my suggestion. Think about this X as a fraction. That means this is X over 1, yes? If you have X in the denominator, X in the numerator, they can cancel. And so you do just have a minus 1. Denominator. X times x is x squared. Plus,
2.
because the x's will cancel again, right? If we're multiplying by x, think of it as a fraction. It's x over 1. X cancels with x. And we just have the 2 left. Okay? Same questions as always. Does anything factor? 2x minus 1, does that have a GCF? No, because there's a 1 in there. X squared plus 2, does that factor? No, it's x squared plus a number. That's never going to factor into real pieces.
Would that be a simplified answer?
Yeah. Does anything cancel?
No.
No. That's it right there, folks. I'm not saying they're all that easy. I know it's intimidating looking at it. But look for that common denominator, multiply it through to start cleaning stuff up. Okay, let's try it with B. Look at the denominators up top and the denominators down below. I want between all of those denominators one common denominator. So, what are the pieces you see?
Why?
You see an x, yes?
Yes.
And you see a
Y.
y. If we have denominators that have x's and denominators that have y's, when you put that together, what's my common denominator?
XY.
xy. Okay? So basically you're just taking anything that's in common, that's a couple of them had x's, a couple of them had y's, multiplying those together. So we're going to multiply every term by xy. Well, that didn't draw right. There we go. So that means on top, I'm going to take 3 over y, and I'm going to be multiplying it by xy. Plus, I'm going to take 7 over x, and I'm going to multiply it by xy. Over, in the denominator, I'm going to take 1 over y and multiply it by xy. Minus, watch out for the minus, 2 over x, and I'm going to multiply it by xy. Okay. On all of these, we're taking xy and multiplying it by a fraction. What is xy as a fraction? You can always make anything you want a fraction by putting it over 1. So, piece by piece.
3xy.
Okay. What cancels in my first set of multiplication? Y in the denominator cancels with y in the numerator, leaving me with what?
3x.
3 times x. On top it's a plus. Second term, x in the denominator cancels with x in the numerator. X canceling with x leaves me with 7 and y. 7 times y is 7y. Okay, repeat the process in the denominator. What cancels?
Y's.
Y cancels with y, leaving me with
X.
1 times x, so 1x or just x. Don't forget, this is a minus. And last piece, x in the denominator cancels with
X.
x in the numerator, leaving me with
2Y.
2y. 3x plus 7y over x minus 2y is where I stand. Okay, you know my questions.
Does it? What is?
Exactly.
Yes.
Does anything factor?
No.
3x plus 7y, nothing in common. X minus 2y, anything in common? Does anything cancel?
No.
If you can figure out the first step, these aren't bad. It's getting that first step figured out. It is doable, okay? That's why I need you to understand. Okay, let's try C.
Wouldn't it just be AB?
I don't know.
Because
What do I currently have as denominators? On top,
AB.
I have a denominator of A, and I have a denominator of B. On bottom, I have a denominator of AB, right?
Yeah.
So if we just looked at the top, a denominator of A and a denominator of B, when you put those together, that's going to be a common denominator of
AB.
AB. Is that what I have in my bottom?
Yes.
So my common denominator is just going to be AB. Okay? So, multiplying everybody by AB. Okay. On top, 1 over A times AB plus 1 over B times AB. We're distributing that AB. Now, what about on bottom?
It's just
It's
A
A
squared.
squared minus
B squared.
It's just one fraction, isn't it? So are we distributing it?
No.
Not really. It's just the A squared minus B squared over AB times AB. We're just multiplying that by one fraction. What is AB as a fraction? What is anything as a fraction?
Over 1.
Put it over 1. Okay. 1 over A times AB over 1. What cancels?
A's and 1.
A in the denominator cancels with, whoops, A in the numerator. 1s I usually just ignore. So officially it's 1 times B over 1 times 1. All we have left is then B plus 1 over B times AB over 1. What cancels?
B's.
B cancels with B, leaving me with
A.
A. Denominator. A squared minus B squared over AB times AB over 1. What cancels? AB cancels with AB, leaving me with
A squared minus B squared.
A squared minus B squared. Does anything factor? Does anything cancel?
No.
Does anything factor?
No. Yes.
Yes.
A B.
A squared minus B squared. We haven't done any factoring like this particularly today, but if you can factor, for instance, x squared minus 25. You can factor x squared minus 25, this is the same thing. Or I think on the front side we factored what? X squared minus y squared. Same idea. So, let's factor. On top I have B plus A. A squared minus B squared. A squared breaks into A times A. B squared breaks into B times B. If it multiplies to be minus B squared, I need plus and minus. What happens here?
A
A
plus
squared
B,
minus
A
B
minus
squared.
The numerator cancels.
That too.
Okay. Is A plus B the same as B plus A? Yeah, it is. It's the same thing as saying, okay, is 2 plus 3 the same as 3 plus 2? Hopefully you guys have been around a few years, you know. So those do cancel. Now, don't mess this up. What is my final answer?
1 over A minus B.
Okay, denominator is A minus B. We still need a numerator. If all else fails, it is 1.
No.
Okay? I know when the 1 is in the denominator, we've just been leaving it off, but you can't do that for the numerator. Okay, D.
You factor both of them first.
I'm going to take a step first, but yes, it's going to be, I hope as you look at that, you see a whole bunch of factoring that you can do. Because that's what I need you to see. But why this problem is different from the others, because here's what I see. I see one fraction divided by one other fraction. All these others, it was adding and subtracting. It was a mess in there. So the idea here is, think about this. If I have one fraction, x squared minus x minus 12 over x squared minus 2x minus 15, we're dividing fractions. So now it's divided by x squared plus 8x plus 12 over x squared minus 5x minus 14. And you may save yourself a step and not write it out like this, but fraction divided by fraction. I already heard it out there. What are we going to do? Yeah, this is a keep, change, flip. So I'm going to keep the first fraction, x squared minus x minus 12 over x squared minus 2x minus 15. We're going to change division to multiplication, and then we're going to flip. So x squared minus 5x minus 14 over x squared plus 8x plus 12. Folks, this is now a problem from lesson 4.3. I was debating if it was 4.2 or 4.3. This is a problem from 4.3. You factor and you cancel. So, x squared is x times x, multiplying to be negative 12, adding to be negative 1, negative 4 plus 3. Denominator, x squared minus 2x minus 15. X squared is x times x, multiplying to be negative 15, adding to be negative 2. Negative 5 plus 3. Other fraction, x squared minus 5x minus 14. X and x, multiplying to be negative 14, adding to be negative 5. Negative 7, positive 2. And x squared plus 8x plus 12. X and x, multiplying to be 12, adding to be 8. 6 and 2. How do we cancel?
You wrote 6. One of them says 6.
Oh, I did, didn't I? Did I say the right thing?
Yeah.
I just wrote the wrong thing?
Yeah.
Okay. I would have been confused here in a moment when I tried to cancel and something didn't cancel. Okay. One piece on top can cancel with one piece on bottom. What cancels? X plus 3's cancel. X plus 2's cancel. Anybody else cancel? Okay. And as long as, keep in mind, you can go straight up and down or you can go diagonals. But that's all we have. So, write out your final answer. X minus 4 and x minus 7 are still on top. On bottom is x minus 5 and x plus 6. Okay, guys. You have a few minutes if you want to use it for homework. I am going to go back and fill in B, but if you don't want to go back and fill in B with me and you would rather work on homework, that's fine. Okay? You guys have what you need on D here? If nothing else, I'm gonna work on B because it puts it in the video, just out of order. So, let's see. X squared minus 1. We're back to needing a common denominator here, right? X squared minus 1 would factor into plus 1, x minus 1. X minus 1 is already factored. Least common denominator. Remember, when you look for least common denominators, look for what's in common. In common between my two denominators, x minus 1. Look for extras. The extra piece is x plus 1. So, both denominators going to be x plus 1, x minus 1. Okay. In the first fraction, what am I missing? X plus 1, x minus 1 are already there, so I'm missing nothing. 4x carries down as 4x. In my second fraction, what am I missing? We have the x minus 1. I'm missing the x plus 1. So we're going to be doing 4 times x plus 1. Put them together as a common denominator. X plus 1, x minus 1. Now, on top, 4x is there. What are we doing here? It's a minus. So as I distribute this 4, I want to think of it as a minus 4. So for me personally, I'm going to write this out as minus 4x, and minus 4 times 1, minus 4. And 4x minus 4x cancels. And so you just have negative 4 over x plus 1 times x minus 1. When all you have is a constant on top, you're not going to have anything canceling. You're not going to have anything to factor. Okay. Okay, guys. Lesson 4.4. Make sure you get in there and get work done on it, right? Get it done. Some of you are getting way behind in Savas, and that's not a good thing.
Is it due tomorrow?
Yes, 4.4 will be due tomorrow.
Okay.
Or at least that